the high price of the day of the index, low the lowest price of the day, and close the closing price of the index. Basically, the closing price of today is the opening price of next day. So that is why if there is a, basically mostly we are working with closing prices because the closing price represents the whole day process of the stock market. But unfortunately, on the few sources of data, there is only open prices, so there is no worry about it. It means the open price of today is the close price of the last day. Just paste the data on the previous tab, then it will be convert into closing prices of the day. So there are 3, 4 indicators of the stock market. So before going to this one, let me make a graph of one indicator of closing prices. Now you can see that there is a huge break, there is a different trend in the series. It means you cannot estimate it with OLS, with co-integration, with VAR, with some other thing, with Granger causality. All those who are doing this practice, they are cheating us, they are trying to manipulate the data. Even though after making stationary this series, you will see that there is a huge clustering. And clustering is a not part of the general econometric modeling. It specially belongs to the archetype family models. So that is why if they are doing this, they are doing wrong. Let's start with the OLS, then we will try to impose a arch, garch. Then you can see that there is a totally fraud which they are running. So this one is the basically raw data of the SP500 closing prices. You can see that there is a huge break and there are different trends. So it means, yes. Basically, there is a debate on long run relation and short run relations. So if someone is claims that this person used arch test and I will use ARDL modeling and I will show that there is a long run and short run results of the variable. So he's doing his practice. He just want to publish a paper in a good journal by saying that there is a, he just try to estimate the short run, but I try to estimate the short run plus long run results. So there is a distinction, there is a important distinction, that is why I am doing this, and you are writing your paper and publishing that one. So this is the cause of publishing paper with that one. I remember a person from India, Prakash Kumar, I think so. Santosh Kumar, sorry. Santosh, he just called me and asked me, I have seen so many paper of yours on financial series. If I want to estimate the long run relationship, I just want to use a Johansson co-integration. Please guide me. I asked him, please share your data. He shared his data with me and I tried so many times but couldn't do this because there is a clustering. If you are trying to estimate Johansson co-integration on this test, you will get significant results. There is no worry about it. But the error structure is totally failed to validate the result. Because there is heteroscedasticity, there is arch effect, there is autocorrelation, and there are so many other problems. So if you want to ignore the residual diagnostics, then everything is okay. So this is the reason. So there is an option to make this series stationary. There are so many tests, but built-in test of the this software is ADF and KPSS. KPSS is relatively powerful as compared to ADF. That is why we are going to use it to make this series stationary. No, I already have stationary series. So for the sake of your understanding, I'm just estimating the stationary series. Now this is the KPSS test. So here is ADF and KPSS. So the result of this one is 2.36732, the estimated value of the KPSS test, and the critical values are very low. So we are rejecting our null hypothesis, which is the series has no unit root, because ADF test null is series is non-stationary, but KPSS null is series is stationary. So that is why there is a rejection. Rejection means the series is non-stationary. Now we are going to take the log to reduce the dispersion around the mean value and the difference of the series, which is known as d log. So I already calculate this d log, but you can do this with, like I am doing this for open d log. Okay. Now it is estimated the d log of open, but I am using close. So now again try to estimate this. Now this time I just fix the stationarity issue of the series, but the pre-model testing is necessary for arch time modeling, because if there is arch effect, then we will go for arch time modeling. Otherwise, we will go for OLS and co-integration time. Arch type basically, yes, volatility clustering. Basically, all the conventional econometric techniques believes that your error structure should be like this. There is no autocorrelation. There is no heteroscedasticity. There is no endogeneity. But if these assumptions failed, it means your model is not good model. But in the case of financial series, the all is the problem of financial series. That is why these conventional models are unable to estimate financial series. They are violating the basic assumptions of the financial conventional methods. Now these are the results. First one, we know that the arch test from first leg to fifth leg, arch test from one leg to 10th leg, but the values are significant. It means after taking the difference and log of the series, there is an arch effect. So after this, we are unable to impose any type of conventional method on this series. So these two statistics basically for the validation of the arch effect. The Q stat basically belongs to the autocorrelation behavior. It shows that there is an autocorrelation in the series, not the residual series. And the Q square stat shows that there is a relationship between the variances of the series. So the relationship between the variances of the series is a problem of volatility clustering. It shows that if there is a shock, then there is another shock. It means the previous shocks creates another shock. So it makes a bunch of shocks. This bunch is called volatility clustering. Like this one, if we take the log of this, just try to make a graph of d log series. Now you can see this one. There is a bunch of shocks. This is called volatility clustering, and the conventional methods are unable to cover this volatility clustering. That is why we are going for Arch-Garch type modeling. Arch is the basic version of this. Some people think that this is a Arch type family. Garch is the most generalized form of the Arch. That is why the people are saying that the Garch type family. So you know that if there is an autocorrelation, if there is a heteroscedasticity, the basic assumption of the conventional method is violated. That is why we cannot do any analysis with conventional methods. So after that, for the sake of more understanding about this one, let's go on the ACF and PACF, AR and MA process. Is there autocorrelation between the series or between the values? Because the basic assumption of OLS is